In the previous section, we set up a network from a biological neuron, also derived the forward calculation that represents signal propagation from cell to cell. We reached out to equation between actual and desired output. However, in the first sight, the calculation seems a bit complicated. We would better to simplify and try to solve basic unit first. In order to calculate an output, we can assign any number to x and w. For example, if we assume x is 1 and w is 0.4, then y would be 0.598. Also, we can arbitrarily assign any number to output such as 0.254. In order to build up difference equation and not to get affected by minus plus values, we can square the difference. We end up with the error function that is the square of difference between actual and desired output. As we discussed before, in order to find the minimum of a function, we need to find the point that derivation is 0. Let's put aside this equation. If you look closely, you can easily notice that the only variable in the system is w. Y is calculated, x is given. The c variable is only changed by w. Therefore, we need to find the derivation of c respect to w and set to 0. However, there is no relation between c and w in the difference equation. Fortunately, we have chain rules to use in the scenario. Let's give a quick break here and remind that the derivation of sigmoid function can be expressed by itself. The derivation of sigmoid is itself times 1 minus itself. Let's put this formula aside too. When we put all the parts into place, we end up the following: the derivation of c respect to w. The w values can be obtained by the multiplication of this value with small number r, which attenuates derivation steps. In general, r is small number between 0 and 1. Before going forward, let's give a break and check if we are on the right track. Let's put the numbers in place and see if the difference is decreasing. As you can see, the difference is slowly decreasing in every step. You can play with different r values to see the effect. The network doesn't contain only one cell. Usually it contains many cells and layers. We are ready to generalize the solution for large networks. Programmatically, we do not need to calculate the previous value for each w calculation. Instead, we can multiply with calculated difference at previous value to current w values. Let's make it clear. Assume we have 5 cells. Since we only know y5 and d, it's easy to calculate c. And calculate the difference based on the formula we derived and saved it in y4, also calculate new w45. In order to calculate w34, we just need to multiply this value with saved value in previous step. In order to simplify, this block shown in different color. You don't need to calculate the yellow part of the formula for each w values. It's already been calculated and saved in the related cell. Next step is just repeating the same process. Same process applies up to input layer. You can stop this process when you reach out to threshold error.